Hello everyone, this is the video lecture of section 1.7, parametric curves. Okay, so let me change my glasses. Here, section 1.7. So, let's imagine that there is a moving particle. A particle is moving along this path, all right? As time goes, this one moving along this path. Then, we want to describe this position of a moving particle as a function of time. So these xy coordinates themselves must be changing over time. So your xy point must be a function of time. Or you can use some f of t, g of t here. Right? Different t values, different xy values. So x coordinate will be a function of time, y coordinate is another function of time. Okay? So here t is called parameter. Now, in our initial interpretation, t was a time, right? If you think this represents position, varying position of a moving object, okay? So in the case we can have x equals f of t, y equals g of t, and a lot of times we have a finite domain, sometimes we have infinite domain, and we call it parametric equation. Now this C is called parametric curve. The set of all points made of xy coordinates following this. Then you have an infinite many points for different t values, right? That forms a curve. We call it, that curve is parametric curve. Parametric curve. You can consider parametric curve is the trajectory curve of the moving object going through, following through. Okay? Now, sometimes we still use parametric equation even though it is not about a trajectory of a moving object. It's just sometimes we just use parametric equation to describe some curve, even though it has nothing to do with moving objects. All right? So in the case, we are interested in actual resulting curve rather than actual parametrization, right? All right. So example 1. Sketch the curve defined by the parametric equation A x equals t is 2t minus 1, b x equals 2t squared, y equals t. All right. So let's think about A first. All right. If you don't know anything about parametric equation, what will be your first approach to understand the shape of this parametric curve? Probably that would be plotting a few points corresponding to different t values, right? So let's do that. T and xy. Let's see. Let's consider these t values. And t equals -1 through 3, then x will follow same value. Y will be -3 -1, +1, 3, and 5. So, -1, -3, and 0, -1, and 1, 1, and 2, 3, and 4, 5, and 5. Okay. So these points, right, as t goes from here. Now if you throw more numbers, -0.9, -0.8, every 1/10, you will probably have these points. In the end, if you think about all the points corresponding to all real number values of t, it'll look like a line. And how do we confirm that this is indeed a line? Well, so far the only things you learned about shape of a graph of equation is when your equation is xy equation. Okay? We know line equation will be a linear equation in x and y. So, can we have a corresponding xy equation out of this? In this case, the answer is yes. Because x equals t, we can use substitution. So what do you get? Y equals t equals x, so 2x minus 1. Yes, it is indeed a line with slope 2, y-intercept -1. Indeed. Now, as t increases, x coordinate also increases, right? So x coordinate increasing means you're going this direction. Alright? Also y coordinates increases. So you might want to draw a graph with these arrows to show the increasing direction corresponding to the direction corresponding to increasing t. Alright? Okay, so this actually another way of describing a line, y equals 2x minus 1. Now, what's the difference between Peronotic equation and xy equation? Your equation in x and y give you only the shape, only the trajectory. But your Peronotic equation gives you more information. Not just the shape of the trajectory, but the whole history of moving positions corresponding to moving objects, possibly. Okay, there is a difference. So Peronotic equation has much richer information. Probably too much if your interest is only about the shape of the curve, right? But if you want to describe a motion of an object, having a shape of the trajectory is not enough. We have to know how fast a point going through a certain position, right? So we need Peronotic equation. In that case, what about B? Let's see, again, txy, t from -2, -1, 0, 1, 2, x is 4 to 8, 2, 0, also 2, 8, y equals same thing. So, 8, -2. -2. And 2, -1. And 0, 0. 2, 1. And 8. All right. 2, 1. No. 2, -1, 2, 1. Okay. Now, if you throw more t values, you will see something like this. Okay. Looks like a parabola. And can we show this is really a parabola? Well, if we can show that that graph is also the graph of a parabolic equation, quadratic equation of x and y, then we can say that this is parabola. Again, we can use substitution. X equals 2y squared. Alright? Hey, this is parabola indeed. With x equals y equals 0 as the x-axis as your axis of symmetry. Alright? And as t increases, y coordinate increases. Y coordinate increases, that means we have to go through that direction. Okay? Alright. Now let's do one more example. Similar examples here. Example 2. Sketch and identify. Identify the curve defined by the parametric equation. P equation means parametric equation. Parametric equation. Parametric equation. Which parametric equation? A x equals t plus 2, y equals t squared plus 3. B x equals 2t plus 1, y equals square root of t. Okay. Sketch and identify the curve defined by this. Again, we're going to use our rich knowledge about xy equations graph. Here, using substitution, we're going to change this substitution. T equals x minus 2. Therefore, y equals x minus 2 squared plus 3. I don't need to distribute. This one gives you your vertex as 2, 3. Okay, going through 4, 7. Something like this. And as t increases, x coordinate increases. X coordinate means going from left to right. So we know that it has to go like this. Okay? Alright. What about B? Now we can write this one as, t equals x minus 1 over 2 and going over there. You can do that. So y equals square root of something about t, square root function. Or t equals y squared. X equals 2y squared plus 1. However, y, square root of t means that y is only greater than or equal to 0. So this is a horizontal opening probe. X-intercept 1. Like this. Okay? But we only choose y is greater than or equal to 0. And then, as t increases, y increases. This is going this way. Okay? All right. Now, if you had, let's say, a remark, what if you had this? So I'm going to do it with, so we're done with this exercise, example, but what if you had this restriction, t is between -1 and 2? Then, from here, x will be t equals x equals 1 and 2. T plus 2 equals x. Between 1 and 4. So between x is between 1 here and 4. Something like this. That will be some finite piece of that parabola. Okay? 4, 7, and 1, 4. Okay? So you have to be mindful about the restriction of the domain. Now, next one is very important. Standard parameterization of a circle and ellipse. Now, before we do that one, you know, x minus a squared plus y minus b squared equals 1. Okay. X squared plus y squared equals r squared is a circle centered at the origin, radius r. Circle with center 0, 0 and radius r. If you have an x squared over a squared, y squared over b squared equals 1. A and negative a, b and negative b. This is an ellipse, right? Of course, here I assume that a is larger than b. If b is larger, it will be vertically longer. Okay? So this is ellipse. Ellipse, probably 12, right? Ellipse with center 0, 0, and major axis 2a horizontally, and minor axis 2b vertically, if a is larger than b. Now, knowing this, let's do the following example. Example 3. Sketch and identify the curves defined by the following parametric equation. A, x equals cosine t, y equals sine t, and t is between 0 and 2 pi. B, x equals r cosine t, y equals r sine t. Again, 0 to 2 pi. Okay? Now, let me check. Yeah, let's include this point again. 4 pi. This time 4 pi. C. X equals r cosine of 2t, y equals r sine of 2t. 2 pi. D. X equals r cosine t, y equals r sine t. Pi over 2, 2. 3 pi over 2. E. X equals sine t, y equals r sine t, y equals r cosine t. Only pi. F, x equals 3 cosine t, y equals 2 sine t. 2 pi. G, x equals 3 sine t, 2 cosine t. Pi over 2, 2. 3 pi over 2. Okay. All right. here, this is a very famous parametric equation for a circle. Why is it a circle? Why it is a circle? Well, think about x squared plus y squared. What is it? Cosine squared t, sine squared t equals 1. So that means you satisfy this circle equation with radius 1 centered at the origin. Now, let's draw. See, what about the direction, the motion? If you think, imagine that this is a location of a moving object, it's a position of a moving object, what's going to be? When so when t equals 0, 0 pi over 2 pi, 3 pi over 2, 2 pi, your x cosine t will be 1, 0, negative 1, 0, 1. Y equals sine t, 0, 1, 0, negative 1, 0. So 1, 0 here. And t equals 0. So 1, 1, negative 1, negative 1. And then negative and 0, 1 at pi over theta t equals pi over 2. T equals pi. T equals 3 pi over 2, 0, negative 1. Negative 1, 0, 0, negative 1. And back to 2 pi. Yeah. And if you consider the other t values, you will find that this is going through this circle counterclockwise, starting from here. Okay? Alright. B. What if you have R? Okay? If you go through B, then you have R squared, it's going to be R squared, sine squared t, cosine squared t. You get cosine squared t plus sine squared t. So it is just R squared. So if you have this, just R, negative R here. So it's just a circle with radius r centered at the origin. Also same direction. Instead of u1, you will have a r minus r. Okay? Now, does it remind you something? X equals r cosine theta, y equals r sine theta, polar coordinate r theta relationship with xy coordinate. So for example, if you have a point here, this is theta, xy coordinate. And theta instead of theta, you have t. So you can imagine that if this is representing a motion of an object, it is going on a circular motion where sweeping angle is same as number of time units. Like every 1 second you go through 1 radian, 2 seconds later 2 radian, 3 radian, 4 radian, 1 radian per second. Constant angular speed. Sweeping counterclockwise direction. So uniform circular motion, right? On a circular path with radius r. Counterclockwise, starting from r0, come back to r0. When you have a 4 pi, then you will go in twice. 5 pi over 2, 3 pi, and 7 pi over 2, and 4 pi. So you're going to go through this one twice. 0 to 2 pi will make you 1 turn. 0 to 4 pi will make it twice. same thing. When you do x squared plus y squared, the r squared cosine squared 2t plus sine squared 2t, in the end, it's just r squared. Again, same circle with radius r. This time, 1 second later, you are sweeping 2 radian, not 1 radian. So this is t equals 0, not pi over 2, but pi over 4 will make it cosine pi over 2, sine pi over 2, so 0, 1. So over here. And t equals pi over 2 will be here. T equals 3 pi over 4. And pi. Because your angular speed is twice, it takes only from 0 to, this is r0, 0r, negative r0, 0 negative r. And see, it takes only pi seconds to make it 2 pi 1 because you have 2t. Angular speed is 2. Right? When t rises from 0 to 1, feeding angle rises from 0 to 2 radian. Okay? But because t covers 2 pi, goes another run. 3 pi over 2. 2 pi, we make it 2 circle, 2 turns. Okay? What about d? Now this time, x gets r. Going back to here, now let's d. Going back to d, same thing as b, right? Same equation as b. It's just pi over 2 to 3 pi over 2. So only over here, here to here. dr to this. No, not this. Okay? So you're going to have just, all right, one term obviously. When t equals pi over 2, t equals 3 pi over 2. That will be the shape. Okay? Left half. Okay? Now E. What about E? You have now x gets sine, y gets cosine, rather than cosine for x, sine for y. Well, if you do this again, r squared sine squared t plus r squared cosine squared, take up r squared, would be 1. So r squared. Again, this is the same circle, right? So what's the difference between E and B? First of all, 0 to pi. And t is 0 pi over 2 and pi, x and y. When x equals 0, 0, 0, and then r back to 0. So you start from 0r here, t equals 0. Over here, t equals pi over 2, and here, t equals pi. You will have only this. Now these are not the part of the graph. If that would be 3 pi over 2 and 2 pi, then you get going back to this, all right? So if it were 0 to 2 pi, you make it one full turn, starting from the top point this time, and clockwise, all right? If you have a sine for x, cosine for y, let's start from the top and going clockwise, okay? Because it is only from 0 to pi, you have only right half. If it were from 0 to 2 pi, it would have been full circle, okay? What about f? Now it's no longer a circle. Then what is it? Then, well, you can consider x over 3 equals cosine t, y over 2 equals sine t. What is x over 3 squared plus y over 2 squared? That is cosine squared t. See? You solve for cosine t and sine t and square. That means x over 3 squared plus y over 2 squared. Well, this is 1. So our xy satisfy this. X squared over 3 squared plus y squared over 2 squared equals 1. That's precisely an ellipse. It is an ellipse. It is an ellipse with 2, negative 3. Now, starting x gets cosine. Think about it. When t equals 0, so 3, 0, right? Starting from here, t equals 0. T equals pi over 2, 0, and 2 over here. Going counterclockwise, just like a circle when you have cosine for x, sine for y. And then when t equals pi, here, minus 3, and 0 over here. And t equals 3 pi over 2, and then 2 pi. Going this way. All right? Zero to 2 pi. All right, this is an ellipse. Plus minus 3 over x, plus minus 2 over y, and counterclockwise turning. What about g? G, well, x over 3 equals sine t, y over 2 equals cosine t. Just like the, instead of cosine, then you have sine cosine. So when you square plus square, sine squared plus cosine squared will be 1, right? So same thing. The xy equation will be same as this, right? Because this will be also 1. You have a same graph as f. What's the difference? Just like the difference between here and here, sine, cosine, cosine, sine to sine, cosine. Here, when t equals 0, you have x equals 0, y equals 2, starting here. T equals pi over 2. X becomes 3, y becomes 0. Going clockwise, starting from here, top. T equals pi. See? 0, negative over here. And negative 3, 0. When t equals 3 pi over 2. 2 pi. Okay? Then, what if you have the following? Let's do the build upon this. What about x equals 2 cosine t, y equals 3, 2 sine t. 0 to 2 pi. B, x equals -1, 3 sine t. Two plus 2 cosine t. So A, what do? X, instead of 2 and 3 here, this is circle. Now if I write x minus 2 squared, y minus 3 squared will be 2 cosine t squared, 2 sine t squared. So it's a 4 cosine squared plus 2. 4 sine squared t, 4 times cosine squared t, sine squared t, so this is 4. So you have a circle equation. So make it adding 2 and 3 into this equation, 2 cosine t, 2 sine t, just makes your coordinate of your center to be 2, 3. Right? 1, 2, 2, 3. Something like this. Okay? Center is 2, 3. Radius is 2. That will be a circle. Now, just like cosine, without this, this will be counterclockwise from this, right? So, starting from here, counterclockwise. Come back to. So this is 4 and 3. Right? Plug it in. T equals 0. 4 and 3. Starting from there, counterclockwise. Because x gets cosine. So from here to here is just the translation. 2 and 3. So your center becomes 2, 3. Then what about B? Same thing. It's a translation of 3 sine t, 2 cosine t. It's just like this, right? It's a translation only. So B, x plus 1 over 3 equals sine t. Y minus 2 over 2 is cosine t. So x plus 1 over 3 squared plus y minus 2 over 2 squared equals sine squared t, cosine squared t equals 1. So you have x plus 1 squared over 3 squared. Y minus 2 squared over 2 squared equals 1. This is the same ellipse. Plus minus 3, plus minus 2, but your center will be -1 and 2. From there, 3 to the right, 3 to the left, 2 up, 2 down. That will be the case if you have a t from 0 to 2 pi. And sine means starting from here. But then, pi over 2. From 0 to 2 pi, if it were 0 to 2 pi, it would have been from starting from here all the way come back to this. That would be t equals 0, t equals pi over 2, t equals pi, t equals 3 pi over 2, and 2 pi, right? Going like this. But then, this one is from pi over 2 to 3 pi over 2, starting from here, not here. Okay? The lower half of the ellipse. Okay? going clockwise. Okay? When you have, I'm sorry, it's 0 to pi. Sorry about that. Then you have to go from here. Sorry about that. I thought that this is, I just read this one. No, this is 0 to pi. Then this is going to be right half. Okay? Alright, so in the end you have x1 plus a cosine t, y equals h and k, h k b sine t, or x equals h plus a sine t plus b cosine t. One of those, both of them will be same shape as both of them give you x minus h squared over a squared, y minus k squared over b squared equals 1. It's an ellipse, okay? Center hk plus minus a, 2a, 2b, right? X, y axis somewhere, depending on hk. And then the first one will be starting from here counterclockwise. Second one will be starting from the top clockwise. And then, you have to look at this domain for t to see exactly where to start. But if it were 0 to 2 pi, it was like this for the first one. This one, 0 to 2 pi from the top clockwise. Okay? So you can do the similar problems in this section about circle and ellipse. These are standard parametrization for circle and ellipse. Okay? If A and B are equal, it becomes a circle. So this covers them all, actually, the standard parametrization. Okay, well, this is the end of section 1.7. Thank you. See you next time.